a particular formalism that enters this formulation of dualities in some situations. And so this is an, well, formally it's an equivalence of graded versions. Of graded versions. Okay, so first I need to make this definition. It will be a little bit incomplete, you'll see. So, so let C be a category, well, abelian or triangulated. Then grading or graded version C tilde of C is another category well C tilde together with a functor to our original category, and then also an outer equivalence S, which corresponds to identity here. I mean, fits into a commutative diagram, and basically we say that for objects in the graded thing, we get a map from sum over n from m to s to the n of n to form well, let me not introduce notation for this functor. I will just sort of abuse notation by using the same letter from object here and object here, but I'll just indicate where I compute the homes. And the requirement is that this is an isomorphism for all mn, and then that the image of C tilde generates C. And the meaning of generates, it's, you know, it means something in the triangulated context, something different in the abelian context. Let's not spend time on this. But so, example is when you have if A is a graded ring with some finiteness properties, maybe Therian, and then C is modules over A, and C tilde is graded modules over A. And the functor just forgets the grading, and of course, as you can guess S of m is a shift of grading. So S of m I is m I plus 1, something like this. So if you shift the grading, then of course you don't change the module, and yeah, and except for the finiteness conditions which I omit, this is exactly true. And so yeah, for this reason I'll just denote S of m also in the future by m of 1 and s to the n by m of n. Ah. Yes, you can. That's a good way to think about it. So yes, what Rama is saying is that the grading can be thought of as an action of the multiplicative group. So that's kind of an example of it's a weak action in Sasha's term. Yes, so weak action of multiplicative group, and then the C tilde is the category of equivariant objects. So yeah, thanks. Yeah, okay, I said I omit finiteness. Discussion of finiteness conditions, so let's skip this. Okay, so yes, and so then definitions of the we'll say that triangulate category C is causal dual to C prime if there are graded versions which are equivalent, but the equivalence is not compatible with this degree shift. Well, maybe we want to call this something kappa, such that kappa of m of 1 is something like kappa of m, and I guess of maybe it's minus 1. But the important thing is that when we do inner degree shift on one side, it corresponds to the composition of homological and inner shift on the other side. So what are the examples of this? So the sort of first motivating example is that if C, so you have a vector space V, and then say over characteristic zero field, and then we have C is the derived category of modules over the exterior algebra, and C prime is the category of modules of the symmetric algebra of the dual space. And so they have this equivalence which sends the trivial representation. I mean, the point is that so I have C tilde is equivalent to C prime tilde, so that the trivial representation on one side goes to the free module on the other side. And this makes sense because kind of X from trivial representation to itself here is a symmetric algebra. So more generally, so if you have if A and A prime are causal dual quadratic algebras, and say for, again, one can do it more generally, but say A or A trig are finite dimensional. This is to avoid subtleties having to do with finiteness conditions. And then again, we have C is dB of finitely generated. So yeah, when I say A modules, I mean finitely generated. So, should I remind the meaning? So, I mean, very briefly, it just says that. So we assume that. Yes. It's the Kazul dual algebra. Okay, so I'll say what it is. So A is a graded algebra. So we assume non-negative grading, so it's sum of AI and maybe we assume finite dimensional graded components. And maybe we assume that A0 is semi-simple. Maybe it follows from the rest, but so the and then it's Kazul if A is Kazul if the following happens. So you can compute X from irreducible to another irreducible. And the grading on A equips this space with another grading, and we require that in fact it's all, so it's is equal to 0 for j not equal to I. Yeah. In other words, and then A shriek is just x'd from the sum of irreducibles to the sum of irreducibles. And there is some beautiful story. I mean, you can. Turns out that any Kazul algebra is given is generated by in degree 1, and the relations are in degree 2. And A3 can be also described in terms of linear algebra, but I will not spend time on this. There is this book by Polyshuk and Positsky that I can recommend. And so 1 is a special case of 2. And I want to give another generalization of 1. I left somewhere my notebook, but that's fine probably. Which will be kind of, it will be easier than example 2 in an algebraic sense, but there will be some non-trivial geometry. So we'll take the following. So we have some base, some x, and so let E to X be a vector bundle. And E1, E2 are some 2 subbundles. And then we can maybe let's just be okay, that's fine. So then we can form S to be the just the fiber product, just the intersection. But again, I want to take it as a derived scheme. So derived. So it means that I consider the DG ring, which is a derived tensor product of this with this over this. And S prime will be the dual data. And so then I take C to be d coh of S, and C prime to be derived category, coherent derived category of S prime. So this is due to Mirkovich and Risch. I guess it can be generalized, but I like this form. And so why do I say that? Well, so I just want to give an example of this, which already appeared yesterday. I mean, one side already appeared yesterday. So Pasha, I internalized Pavel's voice, and it reminded me to use the rug. So yes, exactly. Yes, and for some reason it has your voice. So yeah. Yes, so let a special case. So let X be a point. So E is just a vector space. And E1, E2 are both 0. Then, C prime is particularly nice. So C prime, it just coherent shapes on, orthogonal to 0 is V star, right? So E1 perp is equal to E2 perp is equal to V star. So this is just coherent shapes on V star. So just modules of the polynomial algebra, as simple as it gets. But so this C is slightly more complicated. So it's d coh of this fiber product, like 0 times 0 over V. So as we discussed the other day, it's like dg coh of V star essentially, but place, no, I want to say DG modules over the algebra, and so we had the discussion with Roma about what's a good way to denote it. So I'll use both notations now. So it's lambda of V star by 1. Yes, and maybe O beta. Okay, so there are two things to note about it. First, just kind of this example has two roles. So the first role is to demystify this, because you see that in this case, this is of course the derived category of CMV modules. So this is just to point out that in the special case, it is just the same duality basically between exterior algebra and symmetric algebra, that is the easiest example of this. And the general case, it's kind of the sort, just but then there is something a little bit more interesting happens because we are over a base and things can vary, but it's essentially the same. And the second is to so this is kind of version of example 1. And the second point is that if V is the Lie algebra, which I called GL the other day, then this part appeared this appeared in derived Satake. Equivariant version. No, this is exactly with this homological degree. That's exactly right.
So maybe just make it compatible with
yes, that somehow.
It makes sense to say that it's actually influence of prime wave mechanics would be star.
Right. So one can rewrite this causal duality as some sort of equivalence of. Yeah, then you have to. That's right, yes. As equivalent, as we did, yes, this is a good remark. I mean, C tilde is the derived category of modules of V star, but kind of shifted by 2. Okay, so there is a reason I use different notations on the two sides, but maybe I didn't do it in the way that would make sense. No, the finiteness conditions are sort of the same on the both sides. It's just that what I wanted to say is that it's sort of, maybe this would be a better, and then it's also bound. If you find a way to place B, then you should do it. So what the meaning is that just this is a derived of an abelian, and this is some GG module. So thanks. So okay, so well, this is some formal algebraic game, and to relate it to what we were discussing the other day, we need to pass to start talking about this constructible shapes and D modules, and so examples of causal duality, well, in representation theory. And so the first example was the following. So you have so you start with a finite dimensional group G, and as usual it has B and the maximal the barrel and the maximal torus, and then you consider C to be the derived category of reverse sheaves U equivariant on G mod B. And in this case, actually, C prime is also the same thing. And so this is Zergel. And then there is a generalization, something like this. So you want to also, you can do the following. So we fix two parabolics. Peak.
Is it really true that those two are equivalent to, or is the actual thing that one side is a length dual?
Well, that's a big philosophical debate. Both are true. Both are true. But which one is philosophically? Yeah, that's right. So and which one is philosophically better is, you know, a subject of debate, and somehow, yeah, we can talk about it later. It's also true. Well, if you want, like, or C prime is, yes. Exactly right. And yeah, and then there are different billion cases. They are also equivalent, yes.
There's a theorem historical was that Bezrukavnikov proved that the
Yes. And yeah, so you can also do it in the following. Yes, 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 and this is an important point. Yes, this is also equal to derived equivariant derived category, because this is a unipotent group. So we have to fix two parabolics. And then, so we will. So Sasha talked about this Whittaker D module. So let's bring them here. And so let psi. So we'll denote psi p to be a character of the radical of this maximal unipotent, which is Whittaker has to do with the case when this is non-degenerate and somehow generic, which is so such character, it's automatically factors through the product of a simple roots of corresponding root subgroups. But now I want I want my psi p is non-trivial on psi alpha if and only on u alpha if and only if u alpha is in P. So parabolics, I mean, like in this way to present things, I want them to be standard parabolics containing P. Okay, and so then I can give my example. So this partial with Whittaker sets will be C is the derived category of D modules. And again, you can U psi P on G mod, U psi, well, Q on G mod P, and C prime is derived category of D modules U psi p on G mod Q. So this is essentially equivalent to a theorem of Bennison, Ginsburg-Zergel. Well, if you, I mean, they state it in this module theoretic language, and so so you need to use a result of Milicic and Zergel to restate it this way. But okay, so well, this is just a formal way to state this theorem, but here is the feature, sort of key feature of this thing. So I already mentioned it last time. Maybe let's do it in this regional context. So if lambda is a weight, so then you can associate, so we have a corresponding line bundle on lambda, and we have an element in H2. Well, let's call this C lambda in H2 of G mod B. And it acts on the derived categories, as we discussed last time. It acts on the derived category of all sheaves on G mod B, but in particular on category C. And so it shifts homological degree by 2. But now this is a causal dual. To log monodromy that I described in the very end of last time. Namely, to lambda one can associate an action of C star on G mod B, preserving, I mean, just sort of maps to maximal torus and checks on G mod B. But so my objects here, they are not necessarily B equivariant, and so they it preserves the orbit. So it's and one can deduce that. So F in C prime may not be T equivariant, although one can check that for every T in C star, T apostrophe F is isomorphic to F. And then if we have a choice of this isomorphism for some T, and then we move it slightly, then there is a new unique way to extend it. And so when you start at T equal to 1, and then you move around the loop, and come back, you get a new automorphism. So this is a monodromy automorphism. So continuing along the loop, and get a automorphism which has to be unipotent. So M monodromy and so we get lambda is the log of m, and so this is homological degree 0, but it turns out that it, in the sense of this graded structure, it has degree 2, and so this C lambda is interchanged with L lambda, and yes, as I mentioned last time, it formally resembles some features of homological mirror symmetry. And
This map from C star to T, like lambda started like as a weight, and now you're treating it as a code.
yes, so I can do it. I can either choose a quadratic form and do it on the same side, or more canonically, I can use the second version that. Because it's functorial and it's trivial on irreducible objects, and so by induction and Jordan-Hölder length we prove it's unipotent. But yeah, so right, so let's get closer to what we were discussing yesterday, and so I just want to state that something like this exists also for the for shapes on loop spaces, which we discussed in these lectures. Namely, I claim that so the same works if we replace G by G of T, and B by Iwahori that was defined before. Namely, to be more precise, so you can take example. Okay, I stop numbering them, but so I can take C to be the category di naught. So this is something very close, appeared before already. So, but now let's take di naught on the affine flag, variety, and also C prime to be the same thing. Or we can do so we can also, just as before, we can take so it's called a parahoric subgroup, so it's an analogous, not about parahoric subgroups, PQ containing I, and so and also use some sort of psi there. But so maybe let me focus on one example. So I want to take P to be maybe Q to be G of C of T, as we and P to be I again. And so we arrive at the following example that appeared in my talk yesterday. So this is the so on one side we'll have a derived category of I naught equivariant sheaves on the fine Grossmanian. That's exactly what I talked about yesterday. And so this will be C. Huh? Well, I mean, if you want to refer to results stated in the literature. Yeah, by the way, this is a paper with Yoon, so Yoon and myself. And there, of course, we have characteristic 0. So yeah, so but no, what does it mean? Yes. No, this question doesn't make sense. What could make sense is whether we replace it by the Langlands dual, but which we don't do at this point. Yes, but okay. So when there is this version, so yeah. But yeah. There are various modifications, but this works. And so I mean, okay. So if you want. If you want and ask these philosophical questions, that in this paper with Yoon, we kind of treat a general Kac-Moody case, and then somehow we are forced to go to the dual Kac-Moody group. In that setting, there is only one theorem. But let me stick with this. And so yeah, so but then what is C prime here? So C prime will be closely related.
But is there also like in the fine case if you replace it with dual Kac-Moody get the same category?
No.
But then why doesn't one? It says that for general Kac-Moody case, the dual duality equals to replace Kac-Moody by the dual Kac-Moody.
Yes.
Here you don't.
And here I don't, but it's not arbitrary. It's not arbitrary Kac-Moody. It's not exactly Kac-Moody. It's some you don't have central extension and loop rotation. So let's discuss this later. It's a confusing point. I agree. Okay. So yes. So so what I get here is the Whittaker category. Okay. So what? Okay. I'll write it this way. It's Ivahori Whittaker of the affine flags. So what is by this I mean. D mod. So I take the radical of Ivahori, which I discussed yesterday. So it's matrices with modular, which lies in G of O, and modular uniformizer. They evaluate to something in U, something strictly upper triangular. And so by, as I said, so there's, from what I said, it's just evaluation at t equals to 0. And now I can take a non-degenerate character here. Non-degenerate. And so let's denote now by psi this composed map, and so what I have here is I not psi category on the affine flags, and this is by I think by Sam Ruskin, this is the same as d. I mean, there's certainly a functor to d sort of u of t. Well, maybe I should call it psi tilde. So I think this is not the category. Maybe I'll make it a remark. This is not the category which appeared in Sasha's talk. So remark that you can. Braverman, so he considered D modules on maybe Grassmannian or something else, where he considered a different group, not I0, but loops into the upper triangular group, and this is kind of more infinite dimensional and it's harder to work with, but I think there is a result of Ruskin which says that in this case d I naught psi of flags is the same as d. Okay, and so maybe the only other thing I have time to say before the break is the relation between the examples, which, yeah, I guess it's technically conjectural, but there's no doubt this. It's much less conjectural than other things that were discussed here. So relation between well, if this was example maybe 3, where we had E times E1 times E2 over E, and this duality, Kazul duality for Shibson on affine flags. So this will be just some generalization of derived Satake, and this is well, so it turns out that these constructible categories on the affine flag varieties, they have coherent realizations which are motivated by this local Langlands, and as Sasha mentioned yesterday, well, they now can follow from this big two categorical Langlands conjectures, but this this is known unconditionally. So let me maybe start with the D I naught of flags. And so here we definitely have to pass to the dual group. And okay, so here I'll write notation. So I take the dual group, and so then I have this usual story. I have GL, and it's G tilde L, which is just a stabilizer kind of scheme. So I have X maybe like P in G mod B, and X in G such that X is in stabilizer of P. And it contains, this contains N tilde, where here X is in the nilpotent radical of the stabilizer of P. But so I just want to mention that this is a special case of example 3. Namely, yes. So namely, I'm saying that so if you take E to be the trivial bundle with fiber GL, and then it contains E1, which is N tilde. So this is the condition. So you can think of the flag variety as parameterizing Borel subalgebras, and so here we have this condition that the element lies in the radical, and it also contains E2. So here we have another condition that element lies in the Borel itself. And notice that well, we of course have invariant quadratic form, and the standard thing that orthogonal to upper triangular, so that B perp is the radical. You can put dual if you like. So this means that in this setting E1 perp is equal to, if you identify it this way, then E1 perp is E2, and E2 perp is E1. So there is this funny situation where you so this is self-dual in this sense of this linear duality. So Mirkovich-Risch, so example 3, gives a Kazul autoduality on the right-hand side. And conjectured it but again, this is conjecture that can be proven if needed. So the conjecture this autoduality corresponds to the autoduality we constructed with Yoon on this side. But I mean, it's maybe I shouldn't have worded it this way. I think it's a good project, but it's much more accessible than the conjectures that Sasha was describing.
Do you expect that this theory holds also for deviations?
This one?
Yes.
Yes, for large P, yes. This is what we hopefully we'll write down the Risch, but yeah, with P, if P, yes, if P is not too small, yes. If P is not too small. And also works, so this has, I think it's time to make a break, so I'll not maybe state in complete detail, but let me just say that it has versions. So this has versions where you replace like flags by some parabolic flags, and maybe I should say like Whittaker parabolic versions, just as in the finite dimensional case. But let me just mention the special case that I was focusing on here. Where? Here. Yes. So this perverse sheaves I0 on the Grassmannian. So in particular, so this is just G. It's so derived category here. It's D Koch of this derived scheme G tilde times 0 over G. So in general, will be some T star G mod P here, but so G mod P here is a point, and this is what we get. And so if you still remember, so this was related to this block for quantum group. UQ modules, Lustig. And so this is Kazul dual, so here this is a yes. Maybe lambda was my notation yesterday. Oh. Yes, but it won't be easy. But it's actually, yeah, as my colleague suggests, there should be big quantum group. Yes. UQ mod maybe lambda, that was my so regular block. I mean, so this is kind of like, so this is what we discussed yesterday. This is under the derived sign. And so this is Kazul dual to here, sort of this D Koch. So yeah, orthogonal to 0 is the whole thing, and orthogonal to this is n tilde, and so yeah, sorry, here GL. So you just get this. And it can also be this also has a representation theoretic interpretation, and yeah, maybe I'll skip the detail, but the corresponding Kazul duality between module categories, so remark is that Kazul duality between module categories is in Rish's thesis, and he works in characteristic P. So it's frankly, it's kind of his setting. Well, so in his setting is kind of there's less equivariance, so there's no equivariance here, and this is just like yes, Kazul duality between small kind of between principal block for restricted enveloping and representation of full enveloping, but with a fixed Harish-Chandra central character.
But even if DB Koch of all field is don't require the support.
here in this equations, no, there's no.
And even in TCP version,
So,
also not.
sorry, maybe what I wrote is fine, but maybe, yeah, I already wrote what is causal dual. So this is how I just want to, just to close. So this is D Ivahori Whittaker of X.
So it's cool, but if you want to get equivalence of categories, then automatically we get condition having supported on the 0 squared to 5.
Equivalence.
Because when this n tilde will have to, this n will have to sit on not of molecule 3.
Oh, I'm not sure.
I
Okay.
mean, you're not saying that you mod is equivalent to this in default, the way it's stated. In default of T.
Okay, so let's discuss during the break. So what I wrote on the board is fine, and there is causal duality. I didn't describe it completely. I just said that there is closely related one. Okay, so let's make a break, and yeah, let's continue. And so I just want to briefly talk about one other place where this causal duality appears, the so-called symplectic duality. And so maybe for future reference, I just want to add one more comment.
Question, now would there be a problem session?
Yes.
Okay. And what are the problems? Are they available?
No, first there will be no, but I will provide two problems during the session, but it will start with maybe Pablo presenting some of the solutions from last time.
Okay.
Okay. Yeah, so just some comment on so to add to the finite dimensional case. So since we are working with the equivariant categories, I can mention that their dB of G mod B is equivalent to, well, okay, I'll just write it this way. So it's sorry, it's not one, it's causal dual. And so this is monodromic sheaves, B monodromic sheaves on G mod U with unipotent monodromy. But okay, so this is maybe I'll say a little more about it if I need to refer to it. Okay, so yeah, so another, this is the place where causal duality appears as more recent theory. So this is symplectic duality, so motivated by some physics which I don't quite understand. So to motivate it and connecting to what we did before, so we recall that there's this localization theorem that we kind of had a chance to refer to it in my previous talk. And so, again, going back to the finite dimensional case, so U equivariant sheaves on G mod B. So this is the same as U equivariant D modules on G mod B.
So this case is that case is when you have both cartan and the center there. And the
Here?
right side is none of them.
Right. But this is not derived of the abelian.
It's equivalent.
Yeah, so this is the Streeman-Hilbert correspondence about which we had a chance to talk, and then this is sits inside all D modules on G mod B, and then if you have, D modules in a variety with the Lie algebra action, then there is this functor gamma to G modules, so let's say UG modules. Well, and so here you have 0, so the 0 character. So the center has to act by the same character as it acts on a trivial representation. And so this actually is an equivalence by the famous celebrated theorem of Benenson and Bernstein. And and it's of course also well known which modules over U0 so you get from U equivariant D modules. So this is so-called category O. So these are modules where Cartan acts with generalized integral eigenvalues, and the radical of Borel acts integrably. So yes, well, yes. So it's a category or inside U0. So yeah, okay, that's right. Or 0. So you can say so or 0 inside UG0 modules. U integral and T acts with generalized eigen values. Irreducible objects it's a third subcategory in UG0, and irreducible objects are exactly B integral representations. Okay, so and so because of all this, we know that so we can restate. In fact, this was the original formulation of Jorgel. And Jorgel is that the category O0 is Cazul self-dual. And so, or depending on more sort of for G is Cazul dual to dB of O0 modules for the dual. And so this can be generalized briefly Um, and from the perspective of the theory that I'm going to explain now, it is actually, as Ben was suggesting, it's this version that is more natural. And so this is this symplectic duality, and so definition. So we look at a conical symplectic resolution. So x to y is yeah, I will only consider if y is normal. This is minor technical condition, but the point is that x omega is algebraically symplectic, and we'll always assume that there is an action of a multiplicative group. So x on xy, contracting y to a point which I call 0, and dilating omega by a positive character, which in practice is usually 2 for some reason. And so there's this idea that there should be recent idea is that well, basically that such x so the symplectic resolutions should come in pairs, or roughly. So again, this is some idea, and then there are many interesting examples. So should come in pairs. So there was x to y, and then there was, and I will not try to list all the known examples or anything like that, but let me just say the following. I'll just so the examples that most relevant to me are if x is n tilde, so the T star G mod B, mapping to y, which is this important cone, then x fig should be T star of the dual group, of the flag for the dual group. And then if x is T star G mod P, then to P we can assign, well, P is LU, and then conjugacy cluster of parabolics on the the dual sides are the same, so we have PL in GL. And this is, and then let's take L. Let's take nilpotent E in the Lie algebra of LL. I mean, it should be nilpotent, but otherwise it should be generic. So regular nilpotent there. And let's take y. Let's take y to inside the nilpotent cone for GL to be the transversal slice to the orbit of E. Well, I mean, you can take transversal slice in the Lie algebra and then intersect the nilpotent cone. And X will be its usual resolution, so you can take it to be n star until, well, for the dual group intersected with y, I mean, times y. In other words, it's the pre-image of y under the Springer map. Well, to make it really concrete, let's take G to be like SLN, and the parabolic P to be like this one. So this is n minus 1. So then E is, well, the same type of parabolic. So G mod P is nothing but a projective space. So X is T star P n minus 1. Well, so what's X shriek? I think actually, sorry, I think here I made a mistake in that. Well, more precisely, I didn't tell you quite what the well, I said that the parabolic subalgebras in the dual group signed bijection, but I didn't tell you which bijection it is. And it is not, well, for type A, the dual algebra is essentially the same as, I mean, it's, yeah, the dual algebra is exactly the same. It's the algebraic over SLN, but it's not the obvious bijection. It's not the, it's not the same parabolic, but it's the sort of opposite, dual parabolic. So it's the roots in the levy of in L of PL are exactly the ones, I mean, are dual to roots not in L. So if you apply this So first I need to say what E is. So E is generic in the levy of this other parabolic, which is, I mean, it will be almost the same as Borel, but there will be just one 2x2 block, and the other blocks are 1x1. So the only nilpotent, I mean, the nilpotent is 0, 0, 0, 1. And so this is the subregular nilpotent, and in this case there is a standard point that y is this Kleinian singularity. It's a plane like C2 mod Z mod n acting by generator X by this root of unity, and X to Y. I mean, so it's a resolution where over 0 we have this flag of lines. So there are n minus 1 lines. And so, okay, so I will only mention the right. Sorry. So this is Y Shri.
That X and Y above there should also be dual.
Right. This is all dual. Right. Yeah. This is all dual. Thank you. Yeah. So okay. So this was still about this. Okay. Thanks. And okay, so the one sort of which is the dimension of the cohomology of X should be the same as dimension of the cohomology of X streak, which you can see on this example, right? So it's n in both cases, right? But I will only mention one other feature of this, which kind of meets my story, and then I indulge in a speculation. So we can do the following. So first we can quantize X and Y. So the idea is that I mean the symplectic form on omega, it gives a Poisson structure on symplectic form omega on X gives allows to define a Poisson bracket on X, and then for functions on X, and then global functions on X by normality of Y are the same as functions on Y, and so we have quantization. So the Poisson algebra of Y. For example, for Y equal to n, quantization is exactly this in reductions on the enveloping algebra for various lambda. And two, we'll make this additional assumption And so we assume that on both sides we have an action of a torus I mean, this is a different tori on both sides. Have an action of a torus A shriek respectively, so that both actions have finitely many points. So then we can choose generic co-characters of A and A prime, so that the corresponding the fixed points. Well, so choosing co-characters, we get an action of C star on X. Yeah, so in action of a torus, so sad but didn't write down, so on X omega, meaning it preserves the symplectic form. And then without loss of generality, you can assume that it's also commutes with this dilating torus. Yeah, so that X C star and X shriek C star are also finite. And then then we can define. I will not run the definition, but it's basically you can think of it this way, that you have a category of modules over the quantization is a deformation of the category of coherent sheaves on X, and then we can inside this deformation we can consider the deformation of coherent sheaves supported on the attracting variety of the fixed points with respect to this C star action. So category or for both quantizations. So deforming sheaves on attracting variety. And then the again expectation, which is proved by various people in various cases, and not by myself, maybe by some people in the audience in some cases. So expectation and then theorem in many examples. Well, in particular, the things that I've already quoted can be thought of as a special case from this, is that the category of or for x is kind of in my conventions, I should say. So this category O for x is Kazil dual for GB for x. And yes, as I so I already mentioned this. Yeah, for example, or sort of by localization theorem, this causal duality between d u d of perverse sheaves on G mod B and d of perverse sheaves GL mod BL. So that's my first example. I mean, this is kind of OR for n tilde G. And this is OR for n tilde GL. But also this more general example with slices can also be fit in this way because there is a perverse sheaves U equivariant on G mod P. So this is not, let me not address the most general duality that I presented in the first hour, but let me just say that this is or sort of T star G mod P. And then if I take perverse sheaves for sort of U psi P on G mod B, then this is equivalent to or of that X shriek that there is, I mean, what's involved here is the quantization for the slice is known as W algebra, and then there are results relating category O for W algebra to the singular category O, which is the same as category O. Singular category O on the dual side, and this singular category O on the dual side is related to this partial Whittaker sheaf by Medici-Zerbo. So one way or another, this is known in this case. So, okay, my time is basically up, but I will take a few minutes to just speculate a little bit. And so there were this, just in terms of connecting various things in my talks. So this, the kind of main object of consideration here were these sheaves on affine flags and then coherent categories which are equivalent to those. And, well, these coherent categories involved spaces like this, like T star G mod P or like N tilde, G tilde, etc. So these spaces also appear in this story as examples of symplectic resolutions, and there is this causal duality. But although causal duality kind of appeared in both stories, but so otherwise they are disjoint. But so and even more kind of even more fundamental complaint. This complaint just about this theory of symplectic duality. So, our experience of homological mirror symmetry or geometric Lagrange kind of suggests that a good duality should be an equivalence of, should be relating a derived category of sheaves. And so here it's relating derived category of or, so some sort of subcategories and quantizations. But there is no relation between a derived category of coherent sheaves. And so let me just say that I sort of hope that there is some sort of, that this category or duality, the results extends to a causal duality for coherent sheaves on loop spaces of X and X chic. And I don't think I can literally state or prove this in any example, but just let me finish with this remark that which sort of relates to this is that the equivalence mentioned today which relates some like dB Koch of Canfield GL is equivalent to DI not full. So also conjecturally extends to well, a duality of this sort. So to equivalence or causal duality between the categories on two sides, which are kind of defined in a symmetric way, coherent sheaves on. Well, maybe it's better to state this precisely. So you should have coherent sheaves on kind of. Let me use this language just for the lack of time. I'll just say that it's cotangent to a stack. So T star. So for G and for G check. So considered for G and G check. So a conjecture of this sort appears in my paper with Finkelberg. Where we did a calculation at the level of K groups, and about the same time there was a paper by physicists Kapustin and Saulina. So this called the duality for Wilson to Hooft operators. So in the framework of this Kapustin-Witten theory, this categories of sheaves on flags are called de Hooft operators, and the dual coherent objects is called Wilson operators, but now they kind of united the two concepts in concept of Wilson Hooft operators, which should be the same on the two sides. And so here again, so this is a bigger space and some coherent shifts on something involving loops, and this leads to a conjecture self-dual definition, and I hope that something like this exists in this context. But that's all I can say at the moment. Okay, so let me stop here. Yes?
I have a question about this hope. It seems like from talking to physicists that the causal duality isn't supposed to be between loop spaces of these two things, but loop spaces of some like associated stacks.
Yeah,
like
that's...
Instead of T star Pn, I'm supposed to take T star like C to the n mod.
Sure, I'm all for it, yeah. I mean, that's... Yeah.
But somehow there's like a big difference between those two things.
That's already excessive precision to this level of description, but yeah, I mean, when we make...
How was I supposed to know?
When we make technical... I mean, I didn't discuss this, but of course, I think Ben is referring to the context. I mean, a sort of chapter in this theory of subjective duality. Then when X is something like a quivariate, which is obtained by Hamiltonian reduction, and then there is this construction, proposal for X3 constructed by Garvin, Finkelberg, and Nakajima. And yes, in these cases, I think when people making technical sense of many of these constructions with original X, it actually makes reference not just to X, but from the way to the weight obtained by Hamiltonian reduction. But I think from this, there may be other kind of situations. I mean, of course, in general, T star G mod B for non-classical G is not obtained by Hamiltonian reduction with respect to action of a reductive group. But still, things should still make sense. So this is sort of one ansatz, but then there may be others.
Well, I mean, like in one simple case, like I'm told that X is, I mean, this doesn't fit into this framework exactly because it's not a symplectic resolution, but if X is like T star Gn, then X streak should be like T star shifted of PGn. And somehow, obviously,
Sure.
like, without this stacking, it's hard to see anything.
Yeah, okay, let's talk more about this, but yeah. Any other? Yeah.
Kind of in some situations you explain that from your solution you're getting a causal duality and getting actual proportion of categories, and like somewhere in here you kind of said just slash something.
Yeah.
Like in terms of your hope, could you maybe state
Yeah, that's well, that's actually the point that I was hoping to sweep under the rug, but so I used to think that so you're referring to this, right? Or you're referring to well, okay, so here okay, maybe first let me first make kind of one comment about this setting, and then just to clarify the formal structure of what's being said. So we have of course we have reverse sheaves, like equivalent reverse sheaves on G mod B. Just G mod B sits inside this affine flags, and so there is an obvious embedding here, right? On the other hand, there is a less obvious but still known, well, okay, it's not maybe available in the published literature, but that's yeah, there is an embedding of this into coherent sheaves. Well, on this on the cotangent stack, G mod V mod U, which in fact, if you think about it, it's nothing but it's nothing but the Steinberg variety. This is same as coherent sheaves. Okay. So yeah, you can. I mean, technically, if it's coherent sheaves, mod T, modular carton. This is exactly true. Which is, so this is, this embedding of, you can think of this D modules. You can think of this as micro-localization. In general, it's not full embedding, but in this case, somehow, this procedure of taking associated gradients of Hodge filtration can be bootstrapped to full embedding. And so we, so this should be part of a commutative diagram. If you have this equivalence, then you want to embed everything. You embed everything in a situation where you further do it for the coherent sheaves. I mean, it then can be you can sort of do both. So here we increased. So we started with finite dimensional category 1, and so here we increased it by going to loop spaces. And here we kind of increased it by dequantization. And then we can do both. So we can go to loop spaces and do dequantization, and then we end up here. And then, but now this thing can be compared to the dual side, where, in this setting, there is some sort of debate of whether we should think of this as a equivalence of Cazul duality, but I think in this setting, it's unambiguous. So we have to say that such a category is Cazul dual to the category on the dual side. And now I'm saying that I want to do this pass to loop space and dequantize. And so that Cazul duality should extend to something for coherent sheaves, which then has to be Cazul duality. Okay. Any other questions? What is what? Yeah, it's a maximum unipotent radical of Borel. So for SLN, just strictly upper triangular matrix. I mean, upper triangular matrices with ones of the diagonal. Any other questions? Okay, so stop here.